This becomes Z1 over Z2. It becomes R1 over R2 into bracket cos angle 1 minus angle 2 plus I sine angle 1 minus angle 2. So which means that the W, which is Z over T, it will be equal to Z is, the value of Z is 24 cos of negative pi over 3 plus I sine negative pi over 3 divided by T. So our T is 12 into bracket cos 5 pi over 6 plus I sine 5 pi over 6. So now, with R1 over R2, which is Z over T, will be equal to 24 over 12, then cos negative pi over 3 minus 5 pi over 6 plus I sine negative pi over 3 minus 5 pi over 6. So W finally as is 24 divided by 12, that is 2 into bracket. LCM here, it is 6. It's like we have 1 over 3. We can say it's like 1 over 3 minus 5 over 6. We find LCM. LCM is 6. 6 divided by 3 is 2. 2 times 1, that is 2. 6 divided by 6, that's 1. 1 times 5, that's 5, that's negative 5. So 2 minus 5, that's negative 3 over 6. By 3, 1. By 3, 2. So that is negative 1 over 2. What we're going to do, just multiply pi. So that is cos of negative pi over 2 plus I sine of negative pi over 2. So that is W in the polar form. Another question, they said W power 6. W power 6. You're going to use the Mover theorem. You know when you have Z equal to R into bracket cos angle plus I sine angle. By the Mover theorem, Z power n equal to R power n cos any angle plus I sine any angle. I hope you remember, you remember that one. So if you remember that, we're going to use what? The Mover theorem. So this will be 2 power 6 into bracket cos negative 6 pi over 2 plus I sine negative 6 pi over 2. So finally, W power 6, the answer is 2 power 6 into bracket cos, what is 6 pi over 2? That's negative 3 pi plus I sine negative 3 pi. So that's the answer for number 7. Remember, we are still doing division equations about complex numbers. And we are still with teacher King David. Let's go to other numbers. So we have done polar form of W. We are going to do the standard form of W. So remember, the standard form is Z or W equal to A plus BI. So we're going to write this W in this form. So cos negative pi over 2, that's cos 90. Cos 90 is 0, and sin negative 90 is negative 1. So now the answer is 2 into bracket 0 minus I. So which is 0 minus I. So our W is negative I. This is the polar, this is the standard form of what? Of W. It is negative I. So let's go to W power 6 in the standard form. This is 2 power 6, which is into bracket. Cos negative 3 pi, cos of negative 3 pi, that's negative 1, because cos of pi is negative 1. Cos of 180 is negative 1. So this is negative 1. And the cos of negative 3 pi is 0 plus 0i. So finally, this is 2 power 6, negative 2 power 6 plus 0i. And 2 power 6 is 64. So w power 6 equal to negative 64. So that is the answer. So we are done with number 7b. So we are still on the revision questions. After this number 7b, let's go to number 8. So number 8, we have number 8 because they're still on revision questions about complex numbers. So number 8, it is saying that, suppose that it is known that 1 minus 2i is a 0 of the polynomial. That polynomial is x power 4 minus 3x power 3 plus x squared plus 7x minus 30. Find all zeros of f of x. So this number, it was number 12 Lab 2008. So we have f of x, we have f of x. Our f of x, now we are on number 8. Our f of x is x power 4 minus 3x power 3 plus x squared plus 7x minus 30. But it is known that 1 minus 2i is a 0 of f of x. It means that f of 1 minus 2i is 0. That's what it means. It means that 1 minus 2i, f of 1 minus 2i will be equal to what? To 0. In a complex number, when you give any one root as a 0 of that polynomial, the second root is the conjugate of that one. So that is to say, 1 plus 2i is also a 0 of f of x. That's what it means. So which means that x equal to 1 minus 2i. This is the root. So then x minus 1 plus 2i is a factor. This is a factor. We just bring it on the right hand side. So this means that it means that x minus 1 plus 2i equal to 0. So it forms a factor. Then for 1 plus 2i, for x equal to 1 plus 2i, the factor is x minus 1 minus 2i. So this is another factor. So you see the product will be quadratic equation. So now for the polynomial of degree 4, it means that if we take x minus 1 plus 2i into bracket x minus 1 plus minus 2i times a quadratic equation, which is like ax squared plus bx plus c, will be equal to this first degree, which is x power 4 minus 3x power 3 plus x squared plus 7x minus 30. So if we expand this, it will be equal to that one. So what is the expansion of that one? The expansion of this one, of only this, because we have two roots, when you take root 1, like if we take x1 plus x2 as a root, we'll get sum. And if we take x1 times x2, we'll get product. Then we use quadratic formula in the form of sum and product, which is x squared minus sx plus b. So now, this sum is 1 minus 2i, which is x1 as a root, plus 1 plus 2i. Finally, see the answer is 2. Our sum is 2. Then we get 1 minus 2i times 1 plus 2i. We get product. You know, when you have a minus b, a plus b, the answer is a squared minus b squared. So this is 1 plus 4. Because 2 squared is 4, I squared is negative 1. Negative 1 with this negative becomes positive. So the answer is 5. So which means that this equation is x squared minus 2x plus 5. So which is this times this. The product of this times this, it is this one. It is this quadratic equation. So meaning that x squared minus 2x plus 5 into bracket ax squared plus bx plus c equal to that first degree polynomial, which is x power 4 minus 3x power 3 plus x squared plus 7x minus 30. Okay. So why have I multiplied this with this quadratic equation? So if this is a quadratic equation, I need another quadratic equation to get first degree. That's why I have done that one. So I'm going to expand. X squared times ax squared, that is ax power 4. X squared times bx, that is bx power 3. X squared times c, that is cx squared. Negative 2x times ax squared, that is negative 2ax power 3. Negative 2x times bx, that's negative 2bx squared. Negative 2x times c, that's negative 2cx. Then 5 times a, that is 5ax squared. Plus 5bx plus 5c. So now, that is ax power 4. We have x power 3 here, even here. So it will be b minus 2a into bracket x power 3. Then squared, it is here, here, even here. So it will be c minus 2b plus 5a. It will be c minus 2b plus 5a into bracket x squared. Then we go to x. We have x here, even here. It will be 5b minus 2c into bracket x. Into bracket x. So we have a constant, 5c. Which is equal to what? To first degree. Which is equal to x power 4 minus 3x squared power 3 plus x squared plus 7x minus 30. So what am I going to do? After getting the value of a, the value of b, and the value of c, you know to solve a quadratic equation is very easy. So this quadratic equation, it will give me other two roots. Because now I have two roots. I have 1 plus I and 1 minus I. I'm looking at other two roots so that to get all 4 roots. So let's continue. We go to see how you can get A, B, and C. Then now here, we have 2 equations. We're going to equate them. The equality of equation is here. The coefficient of x power 4 must be equal to the coefficient of x power 4 here. So mean that our A equal to 1 because our coefficient of x here is what? 1. Then b minus 2a equal to negative 3. So from a equal to 1, it means that b will be equal to negative 3 plus 2. So b will be negative 1. Then c minus 2b plus 5a equal to 1, coefficient of x squared, which is 1. So b is equal to negative 1, that is c plus 2 plus 5 equal to 1.